Alright, so at this point, everyone should have finished their intro to Python script. You should have looked at the video on how to add a library that has all of these things. These are the code I wrote for you that you can use as those libraries. Hit the back button. And then you should have also created a new folder called basketball data. And inside the basketball data, you guys don't have this yet. So I'll delete it. But you should have this right here, the basketball data CSV, okay? Because in this folder, we're going to create our first learner. So what you're going to do, same thing as we did with our intro script, you go new Python 2. And then what I want you doing is, you always name it. So we're going to do last name, first name, and obviously don't put these, put your own. And then we're going to call this, all caps, Perceptron. And then we're going to label this basketball because we're going to build a Perceptron. We're going to run it on the basketball data. And I want you guys to put the date. So most of you will be doing this on Wednesday. So it's going to be 6/20. Okay, and we're going to hit rename. All right, so actually, if you want, you can change all these to lowercase underscores. That's the way we've been doing it all of class. Okay, so here's the deal. I'm going to walk through the way I want you doing this, and then we're going to roll through all the code. And like I said, I think it's better if you watch a little, pause, do a little. So the first thing is, this video, I'm not going to give you all the comments, but in order to move on to next assignments, you have to have all the comments explaining what the code does. And the way I'm going to signal I want you to write a comment on what the code does, I'm going to put a hashtag, but I'm going to leave it blank in my video, okay? So I want you to fill it in. So example, the first line of code is going to be import sys and sys.path.append. For me, it's users, Brendan Shelley, let's see, Dropbox / ENC STEM / student code / lib. Okay, but this one will be different based on where your folder is on your computer. Okay, so make sure, I should have made an announcement in the class, but make sure to put the location of your lib folder instead of mine. Okay, and so what I'll do in the video is I'll do hashtag underscore underscore underscore, meaning you have to tell me what this does. Okay, so I'm gonna do it for the first couple, but then you have to do it on your own. This one, and I'll say it in the video. So this line of code tells the computer where to get our libraries. Okay, and then what we're gonna do is I'll say, okay, I want you to write a comment for this. Import machine learning toolkit as MLTK. What this line of code does is it takes that piece of code I wrote for you, the machine learning toolkit, imports it, and then gives it a nickname so we don't have to rewrite the name all the time as MLTK. Same thing, import pandas as PD. Okay, so in the rest of the video, so you see it has a hashtag and an underscore. You need to say, okay, what is this doing? Okay, this is importing our libraries. Cool. And then you run it. Awesome. It ran. No errors. We're good to go. Then, okay, what I want you doing is make this big old thing that says change for different data. Okay, you're going to understand what this means later when we analyze different data. And if you mark this like this, it'll really help. What the three quotations do is it creates kind of like a different color comment so that it's easier for us to pick up. Okay? Alright, so you're going to have to write a comment on the line below. So this one is file name equals basketball, and let's check real quick. we called ours basketballdata.csv. So we're saying basketballdata.csv. Okay, so what this line of code does is it tells the computer the data we're importing to our program. So what you would do is you would erase this and you would say name of the data we're importing to our program. So later on when I don't help you fill in the comments, you can pause the video and you can do it yourself. Last one I'm going to do for you. Alright, this is going to need a comment. So df equals pd.read underscore csv file name header equals 0. And then df.head. So what this does is this one actually goes and gets the data and then prints out the first 5 lines of the data. So if you're doing it, you stop the video and say gets the data and prints out the first 5 rows of the data. Okay, so let's take a look at this. Let's run it. Boom. Okay, so that's our data. So we had a guy who scored 20 points, 8 rebounds, was an all-star. A guy who put 25 points, 19 rebounds, and was all-star. And these guys had all of these stats, but were not all-stars. All right, so this one I'm not going to do for you. So df.tail. What this does is it prints out the last 5 rows in your data just to make sure we got it all. Boom. All right, so that was, looks like we only have about, notice it starts from 0. So when it says 29, that's actually the 30th person because 0 is the first, 1 is the second, 2 is the third, so 29th is the 30th. And then what we're going to do is we're going to create, actually I want you to put a comment right here as well. We're going to create our labels for the attributes or the columns. So the first column is the points, right? So we're going to say data label 1 and then data label 2 is equal to rebounds. Make sure there are no spaces in the names. I'm going to run that, make sure that works. And then, okay, so here we're going to create our map. So here's our map. We need to change all words into numbers. So you do this, it automatically puts the closed parentheses for you. And I would just kind of line them up just to make sure it looks nice. And then, okay, so let's go right here and let's say parentheses class. Because what we're going to do is we're going to replace the class row and we're going to take all these words and turn them into numbers. So watch this. I'm going to say colon and then curly bracket. Make sure it's a curly bracket. That's the one right next to P. You have to hold shift down. And then not. We're going to turn that guy into 0, comma, and then we're going to turn all star into 1. Okay? And then what we have to do, you don't have to write a comment for this. We're going to get all the names. Like this gets the not and the all star just for us. And you'll see why we're going to use this a lot later. So just write this line of code. Not going to really explain it this much. And then what this does, this next line of code, this applies the mapping. Okay? So we kind of made our map. And then this one applies the mapping to our data. Because if you'll look here, remember, this one has to be exactly the same as this. The df thing, that was kind of where we stored our data. And so the mapping indices was our map. And so this one is all coming into a circle. MLTK, that was the library you imported that I wrote for you guys. And it has a really easy function called map words to numbers. All you have to give me is your data and your map. And then I give you the data back, but all words are changed to numbers. And so, if you want to see this, this is kind of cool. df numbers dot head. And let's run this, make sure it works. Boom. So you can see that the all-star, let's see, yeah, the all-star and the nots were changed to 1s and 0s. Cool. And then what we're going to do is, I want you to write a comment for this. We need to name where our data is and then where our classes are. So the interesting thing about Python is it's what we call zero indexed. Oops, sorry. So let me finish writing this and then explain it. So when I say zero index, I mean the first column starts at 0. Just like how the first row it labeled as 0, the first column is 0, the second column is 1, and the third column is 2. So when I say data, our data are our points and our rebounds. So that's in column 0 and column 1. So what I do is data column is equal to 0, comma 1. That's one of those array things. And then the class is in column 2 because it goes 0, 1, 2. So I say my output column, which is kind of my class, is 2. All right? And then what we need to do is we have all our data in one big chunk. But what we need to do is we need to split the data into the, split our whole file into the data and then the sort of the output. And we're going to call this x. The points and the rebounds are going to be x, and this guy is going to be y. So the way you do that is x comma y is equal to, so it's a function I wrote for you in my code. It's called get data, and you have to send it a couple things. We're going to send it and you can copy and paste. Watch this. I can remember Control C copies it. Okay, so I need to send it the data with the numbers. So df numbers comma. I need to send it also which columns are the data columns, so I can copy and paste that, comma, and then I can do the output column. Oops, I think I misspelled that. Sorry about that. Output column. There you go. Okay, and then what I want you to do, let's copy in this. So all of that you kind of had to do for your different data. So if we ever, go all the way down to your last one. Let's say this is where you stop changes for different data. And you'll see why this is important. So if we ever do a different data piece, we're going to start here and change some stuff in between there and there for different data. Let's run this and make sure it runs okay. Yeah, there it goes. So it says stop changes for different data. Perfect. Okay, so now what we're going to do is, okay, we sort of prepped our data, and now, watch this, what we're going to do is we're going to plot the data to see what it looks like. And the way to do this is, it's again in that code I wrote for you, MLTK, so that's the library, and I wrote a function called plot data. So you just need to give me, watch this, the one we ran before, spit out, the x is the points and the rebounds. The y is the sort of class, and you can even see this, watch this. If you don't believe me, you can add under here print x and print y. Watch this, let's rerun it. So look, all our points and our rebounds got split there, and then these are kind of the 1, 1, 0, 0, 0. That's this class data right here, okay? And so we won't need this anymore. This is called commenting it out, because watch this. Once there's a hashtag in front of it, the computer ignores it, and you can just run it again, and boom, it gets rid of it. Okay, so this one, we need to send it the points and the rebounds, whether the y, which was whether it was an all-star or not, and we also need to do a couple other things. We need the x label. We need it. That's one of the things it's looking for, and we say, okay, our x label is just going to be our data label 1. So you can just copy and paste it right there, and our y label is going to be data label 2. And then we also need to tell it, let's see, we have this thing called the legend labels, and we need to send that the class names. And so don't worry about this, it's just one thing it needs, okay? So boom, that's what it should look like. Let's run it and see if it plots our data. So remember, fill in the comment telling me what this line of code does. Boom, okay, so that's our data. So watch, let's look. Okay, this guy had 20 points, 8 rebounds, and he was an all-star. Remember, 1 means all-star. So let's see, 20 points, 8 rebounds. Oh, it looks like it's that guy. So look, the X's are all-stars, and the squares are not all-stars. Okay, so that was that guy. Look, 25 points, 19 rebounds. He was an all-star. So let's see, 25 points, 19 rebounds. Oh, that was that guy. He was an all-star. So this is just plotting our data. So what we need to do is we need to, we talked about this during the lecture, is standardize our data. So that means turning a number between -3 and 3. So put that in the comments. And the way to do that is x standard. We just need to standard the points and the rebounds, so that's why we're using x. I wrote a function for you called standardize data. There you go. But there will be these things called decision trees. You'll learn about this later, where we don't need to standardize the data. So just put this in a little comment. We're not going to use it yet, but we're going to use this later on. Okay, so that's what we call commenting it out, because the computer is going to ignore it, and whenever we want to use it, look, we just get rid of the comment, and then the computer will see it. All right, and then what we're going to do is we're going to plot our new data. So watch this. We're going to do the same thing. We're just going to plot our data. So watch. I'm just going to copy and paste this line of code. But instead of x, now we have this new thing called x standard. Okay? And let's see what standardizing the data did to our data. Let's look at here. Boom. Okay, so instead of the points and rebounds at 5, 10, 15, 20, 5, 10, 15, 20, now they're somewhere between -3 and 3. And so 3 is just how you. That just helps us with our learners. Our learners are able to better do this. And so put in a big comment right here. See the 3 quotations. We'll say, don't standardize for decision trees and random forests. Okay, that'll make a lot more sense later, but we just kind of want to put that out there so we know where that piece of code is. Alright, so then the next line, I want you to do a comment as well. Tell me what this line of code is going to do. This is where we split up our data into testing data and training data. So it looks like this. We're going to call this thing x train standard. So we're kind of splitting up our x standardized data into x train standard and x test standard. And then we're going to split up our y, which is our whether they're an all-star or not, into y train and y test. And then the way we're going to do this is we're going to use one of the functions from my library, MLTK. I created this thing called split data train test. And so we need to send it a couple things. Just like, remember the happy birthday song, we had to send it, LeBron's name and the last message. We're going to do X. We have to send it the standardized data, which we had right here. We're going to send it the Y, which was, as you remember, the Y was whether it was an all-star or not. So we're kind of getting everything from what we've previously done. We're going to set the test size to 0.3. So that means 30% of my data is going to go into the testing pool, whereas all the other data is going to stay in the regular pool. Now we're going to do this thing called random state equals 0. You don't really need to know much about that. And so what we're going to do is now we're going to fill this in. We're going to plot the testing and the training data. So we're going to see what does splitting up the data look like. Okay, so watch this. Here's the beauty of this. You can just copy this. Okay, we're going to plot first. Watch this. We're going to plot the training data. So all you have to do is add a little train right there in front, and then put a little train in the back, because that's what that guy was, right? And that's what that was the training for the X and the Y. So you just put that there, and then watch. You can just copy and paste this below. And that's going to be the testing data. So we're going to add test, and we're going to do Y test. Okay, just so it helps us with knowing which one's which. Watch. You can hit enter, and then put comma. Let's give it a title. So title equals training data, and let's do it. Control Z undoes anything you don't want to do. Let's do that as well down here. We're going to do comma title equals we'll do testing data. All right, so now watch. Let's run this guy here. Boom. So that's our training data. That's our testing data. So watch. All it does is it kind of takes all of our data and just splits it up. 70% goes to the training. 30%, which is not a lot, goes to testing. Boom. All right, so this next one we are going to say is we're going to do a big comment. We're going to do the 3 quotations, and we'll do the pound sign because this is really important. It is where, I'll make it all caps, where to start changing for different learners. Do it all caps again. Okay, so what we're going to do, here's a comment, is we are going to create the machine learner right here. So put in the comment, create the machine learner. So what we need to do a couple things. So we're going to say the learner name. The first one we're going to do is the Perceptron. Okay, so make sure to spell that right. Next one we're going to do is we're going to set the parameter value equal to 10,000. If I haven't covered this in lecture yet, just do it and we'll talk about it soon next lecture. Next one is the parameter name. So the Perceptron takes this parameter name called n iter, and iter stands for iterations. It means the number of times it's going to run through the data. So then we create our learner. So the learner is equal to, we're going to use my library, and I have a function called Perceptron, and all you need to do, watch this, copy this, send me the parameter value. So whatever you stored there, send it to me. And then we're going to say learner, we're going to fit it to the data. So we're going to take the training data, watch this. We had our training data, right? We're going to take our training data and also tell it what the answer key was for the Y train. So we're going to say, okay, this is the data, and that was the answer key, and we're going to train it and so it can learn. Let's run it, make sure we did everything right. Boom, output, that's great. It said we created a Perceptron. So here's the fun part. Now we get to run it and see how well it does. So what we're going to do, this one, is we are going to get the accuracy and misses for the learner on the training data. So put that in your comment. We're going to get the accuracy and misses for the learner on the training data. It looks like this. So watch this. We're going to make the machine learner predict whether the data in the training data, whether they're all stars or not all stars. And so the way you do this is you say, we're going to store it in this variable y predict is equal to learner dot predict, and we just need to send it the training data. We're not going to give it the answers. The y is kind of your answer key. We're not going to give it that. We're just going to get, and that's going to predict it. And so watch this. We're going to collect the misses it got. We're going to collect the accuracy, and we're going to do this by equals always, sets it equal to that. We're going to use this function called performance stats y train, and then we're also going to send it what we predicted. So this was like what it actually was, what we predicted it to be. Okay? And then we're just going to print it out. So tell me what this line of code. We're just going to print out the misses and the accuracy. So we're going to say print misses train is equal to, and then we're just going to add on what the misses for the training data was. And then same thing, we're going to go print accuracy train is equal to, and then we're just going to use that little plus sign, and then whatever our accuracy was. So let's run this and see if it works. Uh-oh, we have an error. Okay. Oops. I misspelled learner. So watch this. We just go back, and let's rerun it. So we had 3 misses. So we had 86% accuracy. That's pretty good. Like if I'm a free throw shooter, that's pretty good. And what we want to do, watch this. We are now going to graph the decision boundaries. So write that in your comment. Graph decision boundaries. So you're going to write MLTK graph decision boundary. So we need to send it a couple things, okay? So we're going to send it, you can copy and paste. We need to send it the X training data. We need to send it the Y training. And then we need to send it the learner we created. So we created the learner. Boom. And then we just need to kind of give it a couple other things it can add to its graph. So the X label was, we called it our data label 1, and the Y label, remember that was where we, all the way up here, let's see, yeah, was our data label 2, you can copy that. That was for the Y label. and then hit enter. And then let's give it a couple more things. The legend labels is equal to the class names. The title is going to equal the learner name, plus we're going to label this as, because this is the training data. Okay. So everything should be good. Let's try running this. Uh-oh, invalid syntax. Let's see, what did I do wrong? Ah, look, I forgot a comma. A comma always needs to separate all these different things, okay? Boom, okay? So look, that's the line it kind of created. So every red dot you see that's on the blue side is incorrect. And every blue thing you see on the red line is incorrect, okay? So now we've done most of the hard work up to this point. What we're going to do is we're going to do the same thing, but we're going to do it for the testing data. So watch this. Let's just copy all of that, put it down here, but instead of the train, we're going to change it to the testing data. And so instead of the training, we're going to change it to the testing data. And so same thing here. We're going to change this to test, this to test, and then so we're going to change this to test, this to test. And we're doing it for the testing data. And then this to test. So I think we have them all. I'm going to hit, or we'll see how well it performs in the testing data. Okay, so it missed 2, but look, because there were less of them, missing 2, they only got an 78%. Okay, and so watch, all we need to do is copy and paste this line, put it right here, but instead of the training, we want to graph how it did for testing data. So let's just change this to test, and then the last thing we need to say is with testing data. Okay, let's run it right here. Boom. So look, it applied the same line. Yeah, it applied the same line, and then this was, these were the outputs. So every box that's on this side is incorrect, and it looks like it got all those correct. So now let's just do it for the total. So watch this. To find the total, we're going to say misses total, and we're going to do accuracy total. And so this is just going to find the misses and the accuracy for all the data. So put that in the comment right there. Okay. So I'm going to use this function. It's a new one. It's called total performance stats. And we're going to send it the Y training the data, the Y of the testing data, the X train standard, and the X test standard. And we also need to send it the learner. Okay. And then all we need to do, watch, is we need to fill in this in a comment. We're going to print out the misses and the accuracy. Okay. So I say print misses total is equal to, and then we'll use the plus, whatever we got for the misses. We'll just do that. And then we'll say print the accuracy total is equal to the accuracy we got there. Make sure everything is exactly typed correctly. Okay. Let's run that. Awesome. And then what this is going to do, this next line is going to graph all of our data and kind of the decision boundary with that. So we're going to say MLTK dot full learner, because we're doing all of it now, output. We're going to send it, watch this, the Y train, the X test, the Y test, I mean, the X train standardized data, the X, let's see, test standardized data, the learner. We're going to send it the X label. We're going to set equal to our data label 1. The Y label, we're going to set equal to our data label 2. And then we need to do that legend labels equals our class name. And then we're going to give this guy a title. So the title is final And then we're just going to say whatever the learner name was, and so in this case it's the Perceptron, plus classifier. Let's see if this is going to work. Run this. Okay, so there's no keyword after argument. So it's got something wrong with this guy right here. Ah, look, I put a minus sign instead of equals. My bad. Whoops. All right, let's run it now. Boom. All right. So look, and you can kind of zoom on in, all of the reds that are in the blue section were misclassified. All of the blues in the red section were misclassified. So we weren't that bad. And look, it was about an 83% accuracy. And the last thing we're going to do is we are going to make it print out how we did with this learner based on its parameter value. We're going to use this function called mltk write analysis to file. So this one's going to be our last line for today. So you're going to say learner equals. We're going to send it the learner name. And then our data file, we're going to send it the file name. And then our parameter name, we're going to set it equal to our what we saved as parameter name. And then parameter value is going to equal to, let's see, and just so you guys can see this, I'll go to the next line. I'll hit enter. Parameter value is equal to the parameter value we created. Okay. Remember to put commas after these. And then watch, I'm going to hit comma. Let's do, okay, so the Mrs. Training is equal to the thing we stored. So look, remember we stored the Mrs. Train, how many we missed? So watch this. This is the Mrs. Train. And then the accuracy training, we're going to set equal to the thing we gathered, the accuracy train, comma. And then watch this. The Mrs. Testing is equal to the Mrs. Test. Make sure it's caps. And the accuracy testing is equal to the accuracy test. And then we're going to send it how much it missed in all. So the misses, all is equal to misses total, and the accuracy all is equal to the accuracy total. Again, this doesn't require any explanation. Let's just run it. Let's see if I ran everything right. Uh-oh, no keyword. Mrs. Training. I used another minus sign instead of an equals. Classic mistake. Let's see. What did I run this time? Let's see. The parameter name. Let's just let's see, our parameter value. Let's see let's see if I spelled it right up here. Yeah, our parameter value. Let's see, parameter name equals parameter name. Parameter value equals parameter value. Let's try to run this. So it's still giving me the error. So let's just get rid of this. Let's see. What did I do? What did I do? Let's try that. Oops, okay, so I misspelled something. My bad. It should be parameter value, so with an A, okay? Then we are done. So watch this. Look at it. It created this new file called results. And watch. It printed out And I'm going to show you how to open this up in Excel, but it printed out kind of all our data. So we ran the parameter 1,000 times. The first time on our training data, we missed 3, and actually it was 0.92. Testing data was 2. We actually was 78. And last one, all our data, we missed 5 and got an 83. There you go. So that was long, but you made your first.